All right, welcome everybody to week 12 or something, 13? I don't know. Week 12, day 1. I don't know if spring break counts or not. 6 weeks left, yep. And we're going to be talking a little bit more today about the glorious hash table. The hash table is my favoritist of all the data structures. And so spend a little bit more time on it. New page. And put it up on 4.5.21. All right. So last time I did an implementation of it. Yeah, so basically, if you're going to be talking about the big O of hash table, there's kind of like an unloaded hash table. So in other words, a hash table that's mostly empty. And that's going to have order 1, insert, search, delete, deleteal, delete. And then if you have a full hash table, or a loaded hash table, smothered and covered hash browns, full hash table, or mostly full, table. Let's call this a loaded. A loaded hash table. Then it's order something, and the big O of a loaded hash table depends on the type of hash table it is. And so we're going to be talking about two different kinds of hash tables in this class. One is called linear probing, which is a form of open addressing and closed hashing. There's a lot of really weird and contradictory terminology. So I'm just gonna use, what we call it. And so there's two different kinds. There's called linear probing that we're going to talk about in this class. There's many different kinds of hashing. But the two options we're going to talk about are linear probing and then with chaining. Linear probing is closed, chaining is open. Yeah, but linear probing is open addressing, closed hashing. So, yeah, it's like don't use opposite adjectives, please. So I'm just going to call them what they are: linear probing and chaining. Okay. So both of them are going to give you order 1 performance in normal circumstances. In normal circumstances, you keep the load of a hash table low. The load of a hash table is what, everyone? What is the load of a hash table? What does the load of a hash table mean? What does that mean? Is it Metallica's 7th studio album? 5th studio album? What does it mean? 6th studio album. Damn. On each side of it. The size of the hash table. So load is a number from 0 to 1. How packet it is. Packet. So load is a number from 0 to 1. And that is what percent full it is, as Mr. Frisbee said. Okay. So a completely empty hash table has a load of 0. A hash table that is completely full has a load of 1. And every hash table has what we call buckets, I guess, slots maybe sometimes. There's a lot of terminology. So 0, 1, 2, 3, 4, 5, 6. So this one has a size equal to 7. So it's got 7 buckets, and currently it's unloaded. It's a load of 0. Okay. So if I were to insert any number into this, then it would be an order 1 operation. So somebody give me an integer that I'm going to insert into here. $51. All right. So 51 goes into which slot? $51 goes into what slot? So 51 How do we know what slot it goes into? 51 modulus 7. 7 times 7 is 49, so this will have a remainder of 2. And so this will go into slot 2, like that. Okay. So somebody else give me number to insert into the hash table. 37. All right, so 37 also has a remainder of 2. So if we are doing linear probing, what happens is 37 tries coming to here, and that spot's full, and so we put 37 here instead. Now, what if we were to insert 38? Well, 38 would try going into here, and that's full, so it goes into here instead. Okay, and so this is the downside to linear probing, is that you'll build up these sort of like plaque clusters of all the numbers, and they start colliding and interfering with each other. So all the collisions from 37 in slot 2 kind of cause collisions in the other numbers and kind of creates these multi-car pileups. And so linear probing has really good performance when it's very unloaded, and it's got very poor performance when it is very loaded. So let's say that we've got let's say we've only got one spot left. Worst case scenario, we've got one slot left. And we're going to insert 2. So 2 tries coming into here. Spot's full, checks 1 to the right. 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 1 to the right. Oh, we went off the edge of the array. We need to use modulus, wrap back around to here. Spot's full, spot's full. So how many slots did we check before we found an open one? In terms of like big O. What kind of big O operation is this? Yeah, it's order n. So worst case scenario for linear probing. Let me select the eraser, please. Thank you. Nope. Can I click on you? Nope, you're doing this to me again, are you? You're doing this to me? Can I click? Can I click? Can I click? You're going to not let me select the eraser. All right, let's try switching out of the notebook. Nope, not working. Nothing's working. Well done, OneNote. Well done. Let's just reboot you then. Such a high quality product. All right, draw. There we go. Nope. There we go. Thank you. So it is order n for linear probing. And that is true for insert, search, and delete. Okay. Now for chaining, there's different kinds of chaining. So the way that chaining works is instead of each 1, 2, 3, 6, 7 of these guys. Again, so what happens is instead of saving the integers directly into the hash table, what you have is you have a pointer here, and so this pointer can be to either a linked list or a BST. What does Zybook show you? Does Zybook show you the version with linked lists for chaining? Yeah, I don't know why. There's really no reason to use a linked list for this. A binary search tree is just completely superior in every way. Like I don't know, because I don't know. I don't get it. There's really no reason to use a linked list, but for some reason everybody teaches chaining with linked lists, so we'll do that one first, I guess. We'll do linked list with chaining with hash tables with linked list chaining. Okay. So let's say we insert, what was the number, 51. 51 comes into here, so it adds it to the linked list. Oops, not 50, 51. And then we insert the number 37. So it comes in here, and it goes to the end of linked list, and it does that. Okay. And the reason why it's not better is because you think, oh, it's just order 1, right? It's just order 1. You got a tail pointer, you got some sort of tail pointer, and you just like slap it on the end. But you can't, because on a if you're doing a set, unordered set, or an unordered map, You don't allow duplicates, right? So you can't just jump to the end and append it, right? You gotta go through the whole thing. Right? So if I inserted 37 again, I couldn't just add 37 here, because if I deleted 37, it would have to delete both of them. I don't know. Maybe you could and defer it to later. I don't know. It seems dubious to me. But basically, it's gonna be yeah. Let's say that we've just added like 100 guys all to slot 2, right? If I were to add like 37, it would have to go through the whole thing to see if 37's in there already. At some point, you might be able to defer that to the delete phase, maybe. But certainly for search, just for simplicity, we'll just say it is order n, right? It is order n for chaining with linked list for insert, search, and delete. Because when you insert, you have to go through the whole thing to see if there's a duplicate. When you search, you obviously have to go through the whole thing. When you delete, you have to go through the whole thing to find the thing you're going to delete. So, worst case scenario, if all of your things hash to the same bucket and you're using a linked list, then it's order n. Okay? Now, if you do it the way that I did it in class last time, which was using a BST instead of a linked list, then every bucket in the hash table is pointing to the root. It's pointing to the root of a binary search tree, right? So if you insert 51, and you insert, I don't know, 37, you insert 2, because I'm using a balanced binary search tree, what would happen is it would fix it. So go from 51, 37, 2 to be this. It'll do what's called a rotate, and it'll fix it. And so worst case scenario, if you have a heavily loaded hash table using BSTs like this, then it's a binary search tree with more steps. Right? You got one level of indirection in there, you're wasting a bunch of memory. But basically the running time is just going to be, if you do chaining with BSTs, then you are going to have, and this is how the Java language does it. Worst case time is order login, insert, search, delete. Okay, so there's different kinds of hash tables. There's all sorts of different methods of resolving conflicts. If you're doing this kind of open addressing, closed hashing kinds of things, there's better versions of linear probing. There's quadratic probing. There's double hashing. You don't have to worry about them in this class. Just know these 3 options. Okay. So any questions about that? You're going to have to implement a hash table for your next homework assignment. So using linear probing. Okay. Don't use the one that I've given you. That makes the assignment too easy. It'll be due in a week. Implement it using the standard library or creating your own. Creating your own. Make your own. You make an array. And when people, it's just going to be for integers. So when somebody tries inserting an integer, you modulus the number to insert. That's the slot in the array you look at. If that spot's open, you put it in there. If it's not, move to the next one. The only tricky bit is when you get to the end of the array, you got to wrap around to the start again. And you're going to benchmark it. So that's going to be honestly what you're going to spend most of your time doing. So, can a vector be used instead of an array? Yeah. Mm-hmm. The only problem with that is some people will use pushback when they use a vector. If you use pushback with a vector, then the array size grows, and none of your hashing works anymore, right? Because in order to find this guy, it's 37 modulus the size, and if the size is now 8, it's now in the wrong place, right? So make sure that you don't use pushback if you're using a vector. Create a vector of a fixed size, or create an array of a fixed size. In this case, probably an array is going to be better, but a vector's fine. Just create it of a fixed size, and then don't use pushback or popback, or everything will break. Can you explain what happens when you delete? Yeah, that's the fun part. Okay. So, deleting from a hash table. There's a couple different ways you can implement this. The simplest method is to do something called lazy deletion. And so you just have another vector of booleans, and that vector would just hold whether there's a valid element there or an invalid element. And so if you were to delete 37, all you do is you change the 1, yes, there's a valid element here, to a 0. And then you just leave everything else the same. And so when you're searching, if you're searching for 37, oh, it's not here because it's invalid. But if you're searching for 38 hashes here, there's somebody here, but it's not valid, then it knows there could be somebody to the right. And just go over that. And the way that you fix this hole in the array is the next time you do an insert, let's say you insert 2, then, oh, this spot's available, and you just put a 2 in there instead, and you change this to be 1. And so that's an approach called lazy deletion, where you just have another vector, and you just say, yeah, that's been deleted. That's it. And you just have to kind of handle that in your code. So if you're searching for the number and you find it, you have to see, oh, has it been deleted? Oh, it's been deleted. Then return false. Okay. But otherwise, you don't leave a gap in the numbers. Because if you were to just delete it and just set it back to, there's nothing there, then you wouldn't be able to find the numbers past it. And so a lot of times you'll have like another vector that holds like, is the spot open? And so for all these slots, like this one is open, these are not open, but this one's open, and then you might have another one for deleted. So you would have like 3 different vectors. Not deleted, that kind of stuff. When you insert and you're going through and you find a spot that's been deleted, you insert in that spot. So that spot's available now. But the reason why you don't reset it back to open is because there's people to the right that might match. And so as you're going along, if you come across somebody that's been deleted, you just keep going, right? And so what happens is the performance of the hash table will degrade over time. And so you can do a cleanup operation where you take everything out of the hash table and reinsert it. And then that'll get rid of any of the holes in the hash table. Like I said, I don't like doing this method. I prefer chaining with binary search trees because it's got a better guarantee of performance. Did the Cybex go over that? I can't remember. Did they go over the deleting for hash table? For chaining, yeah, they're using a linked list. Amateurs. Cybex is hiring, by the way, if you want to work for Cybex. Common hash functions. Let's see. I got delete, modulus. Yeah, mid square is good too. Yeah, how you hash something is actually really interesting. We're just doing integers right now, but they don't have deleting in here. Let's see. Probing. Empty bucket. Empty since start. Empty. Yeah, there it is. Okay. Yeah. So this they do go over this in the inserts removals. Yeah. Yeah. So they mark it as being they're using a magic number, it looks like. So they actually have a special magic number that says this has been deleted. And so whatever number they use there, you can't insert that number into the hash table. Yep, so this Zybooks page here, I would read that and understand that, because that's what you guys are going to be implementing. Okay. So 5.3 on Zybooks. Like I said, the Zybooks is actually really important to understand conceptually this kind of stuff. Probably the laziest way of marking something as deleted. Yeah, like they didn't even do it properly, right? Like if they're using like negative 999 as deleted, then if somebody tries inserting negative 999, it just doesn't work. So the proper way of doing it is to have a couple of booleans for every bucket saying, is this spot opens from start, has it been deleted, etc. Or you could probably merge those into one vector, something like that. There's different ways of doing it. Okay, so let's talk about benchmarking. Okay, so your homework assignment is going to involve benchmarking. And this is an assignment that always brings the server to its knees. The server is not designed as a supercomputer. The server is designed as my own personal Linux box that I do work on. And it is a two-core system. It is not fast. And so for this assignment, you are going to be hammering the server. And so, oh, I'm still running the password cracker. Look at that. Been running that for 300 hours. I guess I can probably kill that by now. 2133763. I forgot it already. Yes. Okay, so interesting. Okay, so yeah, I've been running a password here. Let's see if I turned up any results. Yeah, I can worry about that later. I always run a password cracker on my students to see if anybody has a poor quality password, and then I will invalidate your password, so the next time you log in, you have to change it. Yeah, thank you, Wolf. Is this the benchmarking assignment? So excited. Yeah, I don't know if I did this with you guys. So the just be aware that don't wait to the last day on this homework assignment, because everybody is going to be doing it, and if you don't finish on time, that's your own damn fault. You've been properly warned. You're going to be running benchmarks for hours on the server, and if you do this at a time when 30 other people are all doing it, 1 hour will turn into 30 hours. And you will miss your deadline. Okay, so I will be getting notifications from Linode that my CPU is being hammered. That's fine. Okay, so it's not that bad. So how does it work? Well, so for this assignment, let's see here, cd hash table reference. So there's two parts to it. The first part is you have to write a hash table that will make main really make file. Yeah, don't yell at me. Okay. Make and run it. Okay. So insert, search, remove, change. Okay. Right, so then input file, I don't know, 2. Okay. So here is an example input file. Insert the number 1, insert the number 2, insert the number 3, remove number 1, remove number 2, remove number 3, search for 3. Okay. So this should return not found. 3 is not found, right? So if we run this and we say insert 1, search for 1, 1 is in the table, remove 1, search for 1, 1 is not in the table. Okay. Now, let's let's see. What are some common mistakes people make? Well, a common mistake that people make is they will do a range-based for loop. So if you have a vector, right, like this, right? The single biggest mistake that students make on this assignment is that they treat this assignment as if it's a vector assignment, not a hash table assignment, right? Because you got a vector on the back end, right? So you're gonna have some class, and your class is gonna be called hash table or something, and on the back end you're gonna have a vector named vec of size 100 or something, I don't know. And so when you insert into it, like, they'll just add it to the vector, and when they search it, they just search through the whole thing. And when they delete from it, they just search through the whole thing and call erase or something like that. No, don't do that. Don't do it. This is not, even though there is going to be a vector in your hash table that's this thing, right? The back end of it. Don't do that, because all that stuff is order in. We are not in the business of doing order in stuff. We do not want order in, insert, search, delete. No, don't. Bad. If you guys do that, I will not give you points on the assignment. Okay? Don't have any order in operations in this, when it's unloaded at least. Okay? So people will do things like this, like they'll say for integer x in vec, and they'll just loop over the entire vector. Like for the search function, you know, if x matches the key, return true. Return true. No, don't do that, because this is going to go over the entire hash table. No. The whole point of a hash table is that you don't do that, right? The whole point of a hash table is you don't have to look at everything that's been inserted. If you've got 1 billion people in your hash table, you want to find a person in one operation, not 1 billion operations. Okay? And so what you need to do is hash it. Okay? So, it's like if you're going to do, yeah. So don't have any range-based for loops. Don't have any for loops that run over the whole thing, unless I guess it has to. If it's loaded, you have to. But for an unloaded hash table, make sure that all of your operations are order 1, right? Order 1 if it's unloaded. Okay. If you don't, you're not going to get points. Okay. Yeah. You are going to have a loop, and if you're doing linear probing, it will turn into order n. You will have a for loop, but it should only do in operations if it's loaded, right? If it's not loaded, all of your operations should be order 1. For this assignment, the biggest problem that students do is they will do an order n because it passes the test cases, right? They'll just, like, I know vectors, so I'm just going to say for every element in the vector, if it matches the key that I'm searching for, return true. And they'll do an order n solution when they could have done an order 1 solution. Wrong. Okay? And I will not give you points for it even if you pass the test cases, right? So the test cases are there to make sure your thing is correct, but for this one you have to do a hash table. You must go for speed. That's the whole point of a hash table. It's speed. Okay. If it's loaded, it will turn into order n, and that's fine. That's fine. But I'm just saying, like, you know, let's say you have an empty hash table with just Bill in it. You search to see if Bill's in the hash table. It should jump to the spot where Bill is, be like, Bill's there, return true. Not this, you know, for each name in the hash table, see if it matches Bill. No. Yeah. Okay. So what do we do? Okay. So so 1 is not on the table, so let's insert 100 or 1,000, whatever. Search for 1,000. 1,000's in the table. Change 1,000 to be 2,000. Search for 1,000. Search for 1,000 is not on the table, but search for 2,000. 2,000 is in the table. Okay. So you've got 4 operations you have to support: insert, search, remove, and change. So change changes the value of the value in the hash table. How do you know if the table is approaching load? I would keep track of how many things you've inserted, and you know the size of the hash table, because You use that to modulus the value. For this assignment, you don't need to reallocate or anything like that. Okay. For the assignment, I think it specifies what size hash table you're supposed to use or something like that. So, hash.h. I guess we are going to have to go over the other types of hashing. Yeah. Okay. Yep. So you're going to have to implement this data structure. And I would start off by implementing it with just linear probing and getting it working, passing the test cases. Okay. And then get it to work for quadratic and double hashing, which we haven't gone over yet, but we will. All right, so main.cc. I guess all the directions are actually in the comments. Okay. All right, so yeah, okay. So by default, yeah. So for the input tester, you have to make it size 11. So in order to pass the test cases, you have to change the size here to be 11. For benchmarking, use size. Okay. So do you guys understand this template parameter thing here? So we're passing in 2 template parameters to the hash class that we've made. And we're going to be a hash table of integers, and we're going to be of size 11. Okay. Does that make sense to you guys? You want to see the class again? So you can see right here, we have a hash class that takes in a type. So it's going to hold integers in this case, the most boring vanilla of all data types to hold, and we are going to this probably won't work with anything else anyway, because I'm just using modulus here in the sample code at least. It should probably make a function. There's a function called stud hash, and so you're using a vector, sure, or you can use an array. But like I said, a vector's fine. Just don't use pushback and popback, because if you change the size of the vector, nothing will work. Because all the hashing will break. So there's a function called stud hash that will hash basically all of the built-in types in C++. So they have overloads for string and Unicode strings and ranges, looks like. Yeah, basically most of the default things are hashable. Okay. And so basically, if for example, let's say that you wanted to make a hash table of names. How do you turn a name into a number? Right? There's a lot of different ways you can do it. You just add all the letters together, you can multiply them together, and there's different ways of doing it. My recommendation would be just use the standard library hash, right? If you're wanting to hash a name, it's called stud hash, and it's probably going to be pretty good. So there's a requirement that hashes always give you the same number. So if you hash Bill and I get 72, it should always give 72, right? So when I try to find Bill, it gives me 72 and it jumps to spot 72 and searches there. But hash functions also should scatter them nicely over the entire hash table. So if Bill is 72, Bill Lee shouldn't be 72 also, right? It should be 9,757 or something. Like, so that the hash function should scatter whatever it is they're hashing over a wide area, so you don't get collisions. But it needs to be reproducible. It should always give you the same number. So that would be how you hash a name. And what library is that in? What are you in? Functional. Hash. I would probably put this into its own function, like I did with the other one. I would probably create a hashing function, but we'll just do this here. Stood hash, stood string. Doesn't even know about strings. Class T. D $ escape, Shift J. There we go. Okay, so this will this is a better way of doing it. Before I was just modulusing whatever data was passed in, which means that if you tried passing in a string, like if we tried making a hash table of strings, it wouldn't work. Now it'll work with any type, or at least any type that's that has a hash function defined for it, which seems like a reasonable prerequisite to be put into a hash table. You have to have a hash function written for it. Let's see if this will compile. Let's give it a shot. Unused parameter. Okay, that's off. Okay. So I guess we're using 0 as the magic number here. Again, this is not how I would do it, but if the hash table holds 0, which again would only work with integers, this isn't going to work with strings. Not a very good hash table. It's okay. Your class is only going to be using ints. So again, you should probably have a separate vector holding, is that spot open? Has it been filled but deleted, or has it been filled? I would probably do it properly that way. Okay, so you have to implement 4 functions. You have to implement insert, remove, search, and change. And you're going to have to do these using 3 different types of hashing. Okay. So I guess I said not to worry about them until 26. Let's learn them. So as opposed to linear probing, we're going to talk about quadratic, and we're going to talk about double hashing, maybe. Should I? Or should I just have you guys do linear versus chaining? What do you think, Leah? Linear and chaining? What do you think? Should we have them do linear, quadratic, and double hashing, or linear versus chaining? Normally I do 3 closed hashing algorithms, but I'm open for change. They have linear. Oh, okay, they have about 3 of them here. They have all 4 of them here. Maybe we can have them do 4. What do you think? Can't even remember quadratic and double. Yeah. Well, it's in Zybooks, and so basically with quadratic, what happens is you go up rather than moving 1 to the right every time. You move 1 to the right, then 4 to the right, then 9 to the right, 16 to the right, things like that. So, see if they do it the same way. And then double hashing has a second hash function. So you use 1 hash function to get the initial place. You use a second hash function to get the step size. So rather than moving 1 to the right, you move whatever the second hash function says you should move to the right. And that tends to scatter the values across the array better. I don't know. What do you think? I'll let you make the call. Do you want them to do linear, quadratic, and double, or do you want them to do linear versus chaining? Either is fine by me. You don't get a vote if I'm just Moya. Moya, what do you think? Linear, quadratic, double, or linear versus chain? Since chaining is the standard, yeah, I'm kind of inclined the same way. So I kind of feel like quadratic and double is more of a 26 topic. So yeah, all right. So let's do that. Quadratic it is. Yeah. No, we'll do chaining. All right. So let me just clean this up a little bit here. Hash that scene. So we can't just use the same vector for all of them if we're doing open hashing, right? So let's see, how could we do this? Maybe we just have two different classes. That might be easier. Like one's a linear probing class, one's a chaining class. What do you think? Let's do that. Because I could probably use template nonsense to switch out what it is, but I think just to make it easier on them, we could create one class called linear probing hash and one called chaining hash and something like that. What do you think, Mui? Split them into two. Mui, you still here? Yeah. That's what I do. Okay. All right. So I'll have to retweak this a little bit. Let's talk about and I'll push it out after class is over. So let's talk about the benchmarking side of things. So benchmarking is a really important skill to have in computer science. In fact, most of my graduate career was spent benchmarking because I worked in high performance computing, and in high performance computing, what do you care about? High performance. It's in the name. And so you want to know if I come up with a new algorithm, and this algorithm I think is super awesome and super neat, well, is it any good? You got to benchmark it, right? And so benchmarking means you run your program on a variety of sizes, on a variety sometimes of machines or configurations of the machines, run it on one CPU, run it on two CPUs, run on 100, 1,000, run it across a network, different machines all connected together, and see how its performance stacks up against whatever the default is. And a lot of times your code will be better at some things and worse at some things, and maybe it's good on a multi-core CPU, but not on a multi-CPU system due to, I don't know, the way that the architecture is set up. And so what you do is you benchmark it. You run it hundreds and hundreds of times. You gather all of this data and you plot it. You make a graph of it. You say, this is the performance. Here's n. Here's time. Here's the shape. Here's me. Here's my competitor. The competitor is better at this. I'm better at this. And then you write a paper on it. Okay. And that's that there encapsulates most of grad school, and on top of reading papers. So in grad school you read a lot of papers. Grad school is nothing like undergraduate, by the way. Like a lot of people think, well, 41 is this hard, I'll never be able to do grad school. Yeah, guess what? Like honestly, my experience in taking this class, data structures, was harder than almost any class I took in grad school. Graduate level data structures, it's kind of equally painful. And there were a couple really kind of painful classes, but by and large, grad school is like very easy. It's kind of hard to fail out of grad school. They kind of don't want you to fail out. You can, like, if you don't show up to anything, you'll fail out. But they kind of like, once you're in and you're working with a professor, the professor wants you to succeed because they've invested time and effort and you're helping them. And if you just like vanish off the face of the planet, they're like, I'm not going to get my work done. And so my advice to all of you guys is to go into grad school in computer science if you can. A master's degree is only like an extra year, maybe 2 years of your life, and you'll learn a lot more. You'll get a lot better. So. And a lot of grad school is benchmarking and reading papers. That's it. There's a couple classes that are like traditional undergraduate classes, but most of them are just like 12 people sitting around a table reading papers and talking. And it's a very different experience. Okay. Straight after undergraduate, do you recommend getting some experience? I recommend straight after undergraduate. The reason for that, Emma, is because when you graduate and you get paid $100,000, it's kind of an average salary, sometimes less. One of my students graduated from Berkeley and was offered $170 out of the gate. Do you want to go back to making $19 a year as a grad student TAing a bunch of classes, or do you want to keep making $170,000 a year? You know what I mean? So money is a trap. And once you start making money, it's real hard to, like, you become accustomed to being able to eat sushi every day. You know what I mean? Like, when sushi goes from a celebration to like, I'm just going to pop into Namikaze for lunch every day, or 3 days a week or whatever. You get used to that real fast, and not having a car that breaks down, like, it's crazy. It's a crazy experience. So, a PhD is an extra 4 to 6 to 8 years, something like that. PhDs aren't really useful in computer science unless you want to become a professor or if you want to do research. If you want to do research, PhD is the way to go, I would say. But if you're interested, like I was just interested in becoming a good programmer. A master's degree is really valuable. It's like when you're an undergraduate, you learn everything once at a very shallow level, and then as a master's student, you learn it all again at a deeper level, and you come out of there like pretty much knowing, like, you got a good grasp on things. PhD people just do a lot of research. It's not like you get really good at one thing. It's like if you got your doctorate in autonomous vehicles, then you're going to be really good at autonomous vehicles, and not good at anything else, or not that level of good at anything else. PhDs are usually hyper specialized in one specific thing. So if you're like into something, then yeah, go for it. Why not? Or if you want to become a professor, that's the other reason. I got my master's, then I started a business and did quite nicely, that way. I got into being a professor as kind of a retirement job. Okay. So benchmarking. How do we benchmark? All right. So what business did I start? Just started my own business. Doing, I guess, consulting is the easiest way of putting it. I did a little bit of this and a little bit of that. A lot of educational research. It's actually one of the reasons why I wanted to start teaching. It was because I would travel the country observing teachers teaching, and I would make like an online test. The students would take it. They would go through the intervention with the teacher. The teachers learn some new teaching method. So the teacher teaches them this way. The control group teaches them the old way. Thousands of students take the test before and after. Me measures the difference between before and after. A lot of statistics, a lot of database work. None of it is hard, I would say. None of it's hard, but you just need to be able to, on your own, do all of it. Like honestly, most professional programming isn't as hard as what you do in college or in a job interview. Most of that's harder, but sometimes you get a hard task, you need to be able to do it. You can pick up a master before a PhD, sure, if you want. It's pretty common. Okay, so how do we benchmark? So what you're going to need to do is you're going to come up with input. You're going to have to make them yourself. I'm not going to do it for you. I think I give you a couple examples, maybe. I give you a couple examples. So here is insert search. Oh, look at that. I'm so nice. I give you a generator. Okay. So insert search 100K is 100,000 inserts Right? Followed by 100,000 searches. Okay. So when you run the program, you'll time it. And you're going to time your program for 100,000, 200,000, 300,000, up to, I think, a million. Or 999,999. So I think hash tables don't work when they're completely full sometimes. PhD in underwater basket weaving. Yeah. Yeah. Unfortunately, there's no place in Fresno that really gives a doctorate. I guess Fresno Pacific has like a EdD program, but you know, it's kind of unfortunate. You gotta, like, the nearest place would be like Merced, UC Merced, for getting a doctorate, and it's kind of inconvenient. Does Fresno State have a few? I don't know. I don't think they have one in computer science. So. I'd probably do it at this point, just because I don't have to have an inferiority complex about not having a doctorate, you know. Yeah. Okay. So here's what you'll do: is you will benchmark your code at 100,000, 200,000, 300,000, 400,000, 500,000, 600,000, 700,000, 800,000, 900,000, and 999,999. And you're going to do that for search, delete, and change, and a mixture. And so you're going to run all of these experiments, and you're going to get a ton of data, and you are going to graph them. And that's what you're going to turn in. You're going to turn in an essay. So half the grade is correctness, and then half the grade is producing a report saying what is faster, linear or chaining. And maybe linear is faster at just searching but not deleting. I don't know. Maybe it's better at lower loads, higher loads, whatever. And you're going to write like a little one-page essay, like analyzing it. What is linear probing better at? What is chaining better at? Okay. Dr. Freeman. Will you legally change your name to Gordon Freeman? Yeah. So, that seems like a lot of work, right? What do you guys think? Because you got to run 10 different timings for search, delete, change, insert, I guess. So that's 40 timings, and that's just for linear. Then you got to do it again for chaining, so 80 timings. In each one of those timings, you should run multiple times, like probably 5 times and average the results. So you're talking about 400 different runs. And you got to take all that data and put it into Excel, graph it, and write an essay. So a lot of you guys are probably saying, you know what, I'm just not going to do it. I'll just pass the test cases and call it a day. Don't do that. And the reason why I'm saying that is not because I want to waste your time, but because there's a really important skill you're going to learn in this assignment, and that skill is how to automate. How to not have to run 400 runs by hand, like my friend did. You know, I just visited UCSD over spring break. Muya did too, apparently. And I went walking around the old haunt and seeing all the new buildings they've built there and stuff like that. And it's all closed and kind of depressing. Center Hall, the building that a lot of my classes were in, it was brand new when I was there. It was built while I was there. All the bolts are rusting, and it's kind of like melancholy, like, you know, they didn't keep it up very well. The new computer science building's nice. There's a stone golem outside of it. It's really nice. But anyhow, the point is, like, when I was in grad school, like I said, we did a lot of this stuff. And we'd be in the computer lab together writing code, and we'd finish, and then it was time to benchmark. And so my friend was like, he would spend all week in there running the 400 runs. One after another, after another, after another, after another. And these runs would take like 10 minutes, you know? And then he'd type in, do the next run, and then he'd sit there for 10 minutes staring off into space or browsing the web or whatever. And what I did was I wrote a Unix shell script. I wrote a shell script that did all the runs for me. Run it at 100K, run it at 200K, run it at 300K, run it at 400K. And take all the results, put them into a file, and so I ran it, backgrounded it so it'd run even after I logged off, went to rock bottom. Rock bottom's still there. It was the first bar in the UCSD area outside of Porter's Pub. It's a little pub on campus. UCSD is not a very social campus, and so I would go to rock bottom and play pool and drink beer and stuff like that. And my buddy would be stuck in the computer lab all weekend, like running things by hand. It's like, dude, come out to rock bottom, No, man, I got to do the homework. I'm like, just automate it, dude. Just automate it. I can teach you how to automate it. Just write a shell script that will run all the things for you. You don't have to be a robot. You can just have the computer do computer stuff and run it for you. It's like, no, it just seems too hard. I'm like, you're spending all weekend in a lab to avoid learning shell scripting. It's easier to learn shell scripting. It will save you so much time. So, yeah, UCSD is a great school. I like it a lot. Best weather in the country, honestly. It's in La Jolla, best, part of San Diego. San Diego's got the best weather in the country. So, maybe the guy did not trust the automation process. No, he just thought that shell scripting was too hard to learn. I'm like, I can teach it to you, and so I'm going to teach you guys. Okay. So there's a couple things you're going to have to do. Step one is you are going to have to make the input tests, and so I have given you a program that will generate input files, and so this one is going to, let's see, what does it do? Right. Okay, so this code here is going to generate So this program is going to make a program. This code makes a program that will generate an input file for you. So you don't have to sit there and by hand make 200,000 lines of code. That seems like really tedious, right? And so, like in all things in computer science, if something is tedious, we do a program or a script or something to do it for us. This is one of the most important things that I can teach you guys. Is like, if you ever find yourself doing something repetitive over and over again that's really boring and brainless, you can probably write a program to do it for you. And so in this case, what this is going to do is it is going to generate size random numbers. Size is provided by the command line. When you run it, you're going to type generator 200,000, generator 300,000, whatever. And whatever number you type there is here. Right there. That's how you grab a command line parameter like that and convert it to an int. And so if you type in generator 500,000, size will be 500,000. It is going to generate 500,000 random integers. And it is going to see out, insert that number, insert that number, insert that number 500,000 times. Okay, you don't want it appearing on your screen though. And so what you want to do is redirect the output into a file. And so what data type is A? ASCII. A2I this is a C program. That's a C program, or C function. And A stands for ASCII, so ASCII to integer. And so this is a char star array. C++ doesn't take strings as command line parameters. It only takes char stars, character pointers. So it's a character pointer, which means it's an array of character pointers. Which is, in other words, it's an array of strings. And so argv1 is the first command line parameter. So when you pass in 200,000, that's going to be a string holding 200,000. This converts the string 200000 into the number of 200,000. It will print out the size that you typed in correctly. And then what it's going to do, it's going to generate 500,000 or 200,000 or whatever number you type in, random numbers, and it will print them to the screen. Now, you don't want them appearing on the screen, you want them in a file. So the right arrow there, the greater than sign, what that does, that takes the standard output of your program and saves it into a file. And so when you run the generator, it will generate 200,000, whatever number you put in here. It'll generate 200,000 random numbers, and it'll generate insert that number, insert that number, insert that number. This file is going to be fed into your hash table program. And then it's going to make, in this case, it's doing half of them are going to be removes. And then, so if you have 200,000, it's going to make 100,000 removes. And it's going to be randomly picking people out of the vector and deleting them. So sometimes you'll get duplicates, sometimes you won't. And so this will remove half the elements in the vector. And then it will do 200,000 searches. So maybe we should call this one input search, input remove search 200,000. And so you're going to have to make the generator different, and you're going to have to run the generator multiple times for 10 different sizes. You can automate that as well if you are clever about it. I'm not going to do that for you, though. So if you're clever, you would actually make the generator program generate the files for you, so you don't have to run the generator 10 times. Because you're going to have to run it at size 100,000 into input remove search 100K, 200,000, 200K, 300,000, 300K, 400,000, 400K. So just making the input files is going to be tedious, so you can not do that. You can modify my generator and generate the files in a more automated fashion. So reminds me of Java's string args. Yeah, it's the exact same thing. Yeah, Java takes in a array of strings. This is the size of the array, and that is the array. It's an array of strings. And so this is going to generate one type of input file for inserts, half removes, and searches. So you're going to have to do this for inserts, removes, searches, removes and searches, changes. Okay. So you have to make a lot of input files. And then you're going to run your program on all of those different input files. You're going to run your program for both linear probing and chaining. And you're going to run each one of those 5 times. And you're going to average the results. So how do we do that? So do you guys understand, though, how this generator program works? This is not your hash table. This is just a program that makes input files for your hash table. So when I am benchmarking your code, like with the ELO assignment, and I'm generating these giant inputs for you guys, I'm using programs like this to randomly generate things. I think for ELO, I actually had something kind of cool in it, if I recall. Yeah, so the random generator for the ELO thing would actually come up with like random street, lane, avenue, way. It would actually generate names that were somewhat like realistic looking, and so I actually wrote like a random name maker for it. But file 14. Let's see. 18. Yeah. So you got Weirgive, Duno, Yadu, Koyeski, Dulujiku, Kahu, right? So, of course, you got Puliup, Uka, yeah. So I actually, who lives on Zaxuma Zigzag Street, right? Ifa and Diego Street. So I actually made a random name generator that I'm kind of proud of, I guess. That made somewhat okay looking names. Okay, so cd into hash table. Okay, so what I'm giving you is I'm giving you a couple example input files: 100,000, 200,000, 300,000. Mixtape is a mix of all the different commands at the 900,000 size. Okay, so generator g++ generator.cc. And so if you were to just run generator by itself with, say, 10, you'll see that it'll add 10 things to the hash table. It'll then remove half of them, and it'll then search for a random set of them. Okay, and then it finishes by, I don't know, this, which could probably be deleted. And so when you have your program running, you would feed in, one of these files like this, and then the program would run, and normally it would spit out so look like this. If I fed in mixtape, normally it'll spit out 900,000 lines of text. And when you're benchmarking it, you actually don't care, right? Like you've already run the input tester. You know that it's correct. So you can actually discard all of the all the text because you know it's correct. All you care about is the timing. And so if you want to run your program with a mix of insert, searches, deletes, changes, and removes, and you don't actually want to see the output, what you can do is you can redirect the output into dev null. What is dev null? Dev null is like a trash can. Okay, so anything that you write to /dev/null goes away. It does not appear on the screen. Okay, so if I were to run this program now, it's going to read from mixtape 900K. Normally, right, if I run the program, it just reads from the standard input. Right? Insert 1, switch 1. Right? So if I normally run the program, it reads and writes the input and the output. This is the standard Unix way of doing things. If I want to have it read from a file and have it think that it's reading from the keyboard, then I do this. So by doing this, the program is going to be reading from mixtape 900K and writing the output to the screen. So if I were to just say a mixtape, you will see it will print 900,000 lines to the screen, which I don't want. And so what I do is I say, rather than reading from the keyboard, I want you to read from a file. And so the program is going to read from this file, 900,000 lines of input, times 4 probably, something like that. And instead of writing to the screen, write to dev null. And if you do that, you will see the program does that. Nothing. Why does that matter? Well, now we can tell how long it takes. Time. Okay, so that took 2.6 seconds. Okay. So if you use the time command and then you pass it a command parameter or command line command like that, it'll actually report to you how long the thing took to run. So if you do this with all the different input files and you just take that first value there, which is the most important one, then you'll get a set of timing values, how fast your code is. And if you don't want to see all this other stuff here, this is the amount of CPU time spent in the user time. This is the amount of time spent in the system time. This is the wall clock time. Maybe that one might even be more useful. I don't know. I would just graph this one. This is the easiest to get at. How many page faults, how many I/O things. Okay. And so what you can do is you can pipe the results through cut. Field 1 delimited by space. Remember how we talked about this before? ambiguous output redirect. Thank you very much. Yeah. Oh, rather than getting into the weeds here, I've given you a timing script that will do that for you. So if you check in the directory after I push it out to you guys, there is a shell script. And this shell script will do all of the timings for you. You feel like it's above your intelligence level? Good news, I've given you everything you need. Okay. So this is a shell script that will automate everything for you. So you could run all those things by hand and hate your life, or you can embrace the joys of shell scripting. Okay. So right now the code is going to run. So seek02 produces the numbers from 0, 1, and 2. And so what it's saying is for each number in the range from 0 to 2. So it's going to run it once in mode 0, linear probing, run it once in mode 1, quadratic, run it once in mode 2, double. We're going to be changing that, though, to this. Mode 0 means linear. Mode 1 means chaining. Okay. What the heck is all this? Yeah, well, I'm explaining to you. So this is a shell script. This is how you do automation, right? Like I said, in CSI 40 and in CSI 41, the more Unix you know, the better off your life will be. And this is a great reason. This is a great example of it. You can use shell scripting to automate your stuff so you don't have to run it by hand 500 times. So what does this do? All right. Well, this is going to run the program in mode 0 a bunch of times. So it's going to run all of your linear probing stuff first, and then it'll do it all again in chaining mode. And so it's going to run for every input file in here. For every input file in here that, you know, so what this will do is find every file in the current directory that starts with mixtape. So if you've made 10 files, mixtape 100K, mixtape 200K, mixtape 300K, mixtape 400K, 500K, 600K, 700K, 800K, 900K, and 999K, it'll find all of them. And what it's going to do is it will run your program in mode X, remember X is the mode, passing in that file, Y. So if you have mixtape 100K, it will run your program in mode 0, say linear probing, with mixtape 100K passed in, and it will run it 5 times. And what it will do is time your program, passing in the mode, passing in the file, redirecting the output to dev null, like I just told you, cutting out everything before the U, and so that will give you how long the program took to run. And it will print this to the screen. And so what you're going to do, what you're going to see is when you run this program, when you run timing script, the only file in here I have right now is mixtape 900K. So what you're going to see is it's going to run 5 times, and it's going to print them to the screen. So all you have to do is copy and paste this into Excel. Okay. Shell scripts basically run commands you put in the command line, but from a file. Yeah, exactly. So for example, if I wanted to make a shell script called muya.sh, sh is the typical thing, I could just say echo hi Nick, like that. Make it executable like that, and then I could just run it like a program. It's a program. Look, it's a text file, but it's a program. It's a text file, but it's a program. I just made it an executable by adding the execute flag to a text file. And if you add the execute file to a text file and you try running it like it's a program, it's not a program, it's a text file. You know, if you try vimming a.out, it looks like this is what your program looks like if you vim it, right? If I vim muya.shell script, it's just text. But Unix will run, if you give it a text file to run, it will just run all the commands in it. So if I run muya.sh again, it just prints hi Nick, I like turtles. So whatever commands you put into a text file, you can just like literally, if there's like 10 commands you do over and over again, I like turtles. Yeah, you got the reference. Good. If there's like 10 commands that you do over and over again, you can just put them into a text file and just run it, and it'll do all 10 commands. It's really easy. It's really straightforward. And so rather than you need to figure out this timing shell script, because you're going to have a lot of input files, you're going to have a lot of things going on. I'm just giving it to you. Okay? And so all you need to do with the timing script is this. Okay? That's the only thing you need to change. Because whatever you name your input files, you have to change that to match it. Okay, so if you create a bunch of files called mixtape 100K, mixtape 200K, then that will find all those. But if you call the files Muya's awesome input files, it won't find it, because this is only matching. This is only matching on files that begin with mixtape. Okay. So basically, every line in the script could be run individually from the command line. Yep, all of these things could be. For each echo I like turtles. End. So for each is a shell command, and it's saying for each x in the range from 0 to 1. That's 2. Let's make it a little more interesting, I guess. 1 to 10. 0 to 10, so it'll do it 11 times. And I'm just going to print, I don't know. User bin fortune. Which fortune? User games fortune, sorry. User games fortune end. And so that just ran the fortune program 11 times. Okay. And so yeah, all those things are just command line things. That's all it is. So shell scripting, I've talked about it before, but this assignment will drive home to you guys why it's so important to learn automation. Because you can have a life that sucks and is full of drudgery and everything's in grayscale, or you can have a life in full color with Unix, the power of shell scripting on your side. So what I'd start off for now, I need to clean up that file, because I do kind of want to change it to go from being 3 different types of closed hashing to 1 closed and 1 open hashing. I need to clean it up a little bit and maybe make a README file for you guys. But basically, the first thing I do is just get the hash table working, have it pass the test cases, and then after that, work on the automation side of things. Okay? So, what are the limitations on using shell script? It's slower than C++. It doesn't have a lot of the... Shell scripts are really good at doing like quick and dirty kinds of things. They're not good at doing like full-on programs a lot of times. Anyhow, so when you're done, you're going to end up with like a bunch of timing data, like 1 millisecond, 11 milliseconds, 22, 40, 60, 100, 120, 140. What you're going to do is you're just going to take all these numbers into Excel, and you're going to graph them. Okay? Where'd you go? Data. Where are you? Draw, insert, graph. There we go. Yeah, and so you just make a little graph like that, and down here is the number of elements you're inserting. Over here is the time. You're just going to make some graphs. You put them all in one graph if you want. You can do 10 different graphs if you want. But basically what you're going to do is you're going to come up with just like as the load goes up, how does the running time go up? And you're going to write a little essay. What's faster, linear or chaining? Okay. And it's not always black and white. You know, could be that linear is faster at low load, chaining's faster at high load. Spoiler, it probably is. Okay. I was talking to a programmer friend. He mentioned the architect. So the architect is the person who made the matrix. It's an AI program that kind of oversees the matrix and kind of makes sure everything's going according to plans. Neo meets him, I think, in the second and the third movie, I think, if I remember correctly. If you're talking about a software architect, then those are the people that make the big level decisions about how everything fits together, right? Like if you've got a big product and it's got a lot of different moving parts to it, like Twitter or something like that, right? So with Twitter, you've got like a user authentication part where, you know, you got a user creation part where people are making accounts. You got user authentication where they're trying to log in and, you know, getting rejected. And you got a moderation thing where like the moderation team needs to have tools to delete tweets. And then you've got a viewing tool that can view tweets, a messaging tool where people can send messages to each other. So there's a lot of these different parts of Twitter, and Twitter all used to be in one source code file. So when my buddy started working at Twitter, they hired him because Twitter was all within a single source code file, and it wasn't working very well. And so he split it into, so he re-architected Twitter. It was all in just one source code file, hundreds of thousands of lines of code, one file. And so and it would crash all the time. Twitter used to have the fail whale. When Twitter would just go down, you know, and you'd display this whale. So it's called the fail whale. And so what my buddy did, and you can see his talk online about how he re-architected Twitter. And so he split it into like 30 different files, which allowed and created modularity between them. So the different components had defined interfaces, like what we're doing in this class, like a public interface and a private interface, right? So the different parts of Twitter would talk to each other through interfaces. So if one part went down, it wouldn't crash all of it, you know? So that's what an architect does. It's like the big high-level decisions about, and now how do these things talk to each other? How does this fit together? That kind of stuff. Sounds like OneNote needs a new architect. I don't know. I don't even know. It's like, it just seems like a really trivial bug. Like, I don't know. Software engineer on steroids. Yeah, it's like, it's like more even high level than that, you know, like, you're probably not even writing code maybe at a certain level. You're just like making decisions about, okay, who should have the ability to authenticate, you know? Where does that responsibility lie? Who talks to the database, you know? And so you could write code, but a lot of it's just big decision-making stuff. And project management, yeah, but you have to understand software engineering at a really deep level. So typically architects are people that have been coding for a long time and understand not just how to code, but also how to build big, complicated systems and have them work, because that's hard, right? It's really easy to make a Facebook clone that works fine for 10 people or 100 people and doesn't work for 1,000 or 10,000 or 1 million, right? And in order to get Facebook to be successful, they had to re-architect Facebook several times to get it, because originally they kept it in check by just having each college having its own Facebook. Right, so Harvard would have its own, and Princeton would have its own, and because nobody could talk to each other across the sites, it kept the complexity under control. But eventually, Zuckerberg hired the right people with good architecture experience, and they re-architected Facebook, and they had to switch out their back-end databases. Like they had to do, like it was a really impressive engineering feat. I mean, as much as, you know, people hate on Facebook, and, you know, for good reasons, from an engineering perspective, it's quite an achievement. And so, you know, that's a job you could have if, you know, you got to get out there, you got to get experience, things like that first. Definitely not a PhD. Yeah, PhDs are like I was talking with a recruiter, a headhunter, and he didn't like hiring PhDs because he thought they're all eggheads that couldn't actually write code. It's like, I want to hire a master's student, I don't want to hire a PhD. A friend at Twitter told me they were learning Scala. Yeah, that's why my buddy decided to apply for Twitter, because he liked Scala. He's like, what companies? Google. What companies do Scala? Twitter. Holy smokes! So he applied there. He's like, hey, I want to work for you guys. I love Scala, and they hired him, and he re-architected Twitter for them. Like I said, you can find his name's Brian Dagenhart. Used to be a male model, among other things, and you can. He's a friend of mine from college, and a really cool dude, really awesome dude. He fantastic individual, and yeah, like I said, you can Google him and see his talk on how he redid Twitter. It's pretty cool. So that's it for today, guys. So I will push out the new homework assignment. Those of you that have done the linked list take 2, you might notice that Canvas barfed and did not display the 4th question. If you did not get the 4th question, I have put a supplemental competency exam for linked list up. So if you got exactly a 2 on the competency exam and you need that last point, do it online. You'll have 20 minutes to write a function using linked lists. And if you do it right, you'll get a 3, which will allow you to pass the linked list competency exam. If you got a 1, don't bother. It won't help you. I guess it'll give you a 2. Might as well. If you got a 3 already, if you got a 3 out of 3 on the previous one, you don't need to do it. Okay? And then there's going to be another iteration of competency exams coming up, which we will talk about in the future. Okay? Just worry about that for now. Thanks, guys. If you have any questions, feel free to post on the Help Center, etc., etc. All right. See you guys.